Hi everyone, good morning. So my name is Anirudh and thank you everyone for joining in on our webinar today on how to control costs and minimize cloud waste with Terraform. We also have AWS with us here today. Give you the next slide, Nadia. A few housekeeping rules before we start. So anyone who automatically joins the webinar will be muted. However, if you do want to communicate something, we do have the Q&A section and the chat window. So do let us know your thoughts through that, and we will definitely have someone address them. We want it to be as interactive as possible, so please do go ahead and ask questions during the webinar. Like even if someone's speaking, just go ahead and ask a question. It'd be nice for everyone to, know what's happening, know your thought process too, right? So let's have that. There will also be, a Q&A section at the end of the webinar if anyone has questions post the webinar. And as usual, the slides and the recording will be available to you guys after the webinar. A slight introduction to AspireNXT. AspireNXT is a partner with AWS and Terraform. We are an advanced consulting partner, and as an organization, we are a digital transformation firm. As it being a digital transformation firm, we work with a lot of organizations to bring digital solutions to them to cater to any industry and also help in transforming them and their roadmap. We've been working for 12 years and we've been working across 8 countries. We have more than 500 customers worldwide, as well as more than 1,000 projects delivered. Here you can see our competencies from an AWS perspective. We are an advanced consulting partner, like I said, and something that also sticks out is our well-architected partner program. We have a few partners globally that work on the well-architected framework along with AWS to deliver it to their customers, making sure that all customers are built in a well-architected way. Speakers for today. So my name is Anirudh. Like I said, I'm a technical consultant with AspireNXT. I head up our core cloud practice. We have Desmond from AWS. Desmond is a partner solution architect. He focuses on storage and has a rich background coming from IBM. He brings his skill sets to enterprises and organizations. And then we have Cheryl. Cheryl is a partner solution engineer from HashiCorp. She'll be helping you through the demo. She's very good at what she does. We've done a lot of webinars together, Cheryl and I, and we, from a technical perspective, also she's able to bring hands-on experience to everyone. Right. Cool. So without further ado, let's begin the webinar. Now, globally, a lot of organizations, right? They have this very ad hoc manner of adopting the cloud, and this stems from a lot of thought processes where people are like, let's just go ahead and use the cloud for this, let's use the cloud for that. But along the way is where cloud waste arises, right? And what is cloud waste, right? Cloud waste could be any resource that's underutilized or over provisioned resources, right? So say you have a workload that requires 4 cores and someone provisions 16 cores, right? You have almost 12 cores that are just not going to be used. So that's an over provisioned or an underutilized resource. So that contributes to cloud waste. Then you have the ungoverned or ad hoc deployments. So someone has access to an AWS account in an organization. He goes and he deploys a resource or a service for R&D, and then that service is just left unused, right? Now that's a very ungoverned and ad hoc deployment. And then you have resource misconfiguration, like I said. If a resource only needs 4 cores, why do you have 16 cores for that resource, right? Or if you only need 10 GB, why would you provision 40 GB? So all of this contributes to cloud waste. Now, how do we solve this issue, right? You can go ahead, Nadia. Right? So if you can see the screen, today an organization begins their cloud adoption journey with AWS. So they started with a couple of POCs, and you have one AWS account or a couple of AWS accounts for these POCs, and you have a single cloud team. And then you migrate an application, and you see That line dictates the rise in cost. You migrate an application to the cloud, and there's a certain cost associated to it. Now, as they progress, as they mature as an organization in the cloud adoption, they start their cloud center of excellence. Now, the cloud center of excellence, their main job is to make sure that the cloud is well utilized, right? So they are able to use optimization techniques and bring the cost down low. It could be by just cutting off those POC accounts. It could be by leveraging various cost saving factors that Desmond is going to bring in today from an AWS perspective. But then you have multiple teams that start using the cloud again, right? And then you have dev and test environments. You have another application. You have more dev test environments. You have more applications, more POCs on the cloud, right? And slowly but surely, the price is going to increase when you're on the cloud, right? And that's when the management comes in and is like, hey, why am I paying so much for the cloud spend, right? So how do we fix this, right? How do we make sure that organizations are leveraging the cloud to the best, to their best capabilities, but also doing it at a cost efficient manner, right? The answer that we found is to be infrastructure as code, right? Infrastructure as code brings in governance, it brings in consistency, and it brings in cost optimization, right? How does it do this? It brings it in because everything is code, right? To any developer out there, everyone would know code is law, right? Uh, even if you're from a cryptocurrency background, you'd understand how code is law, right? So keeping that in mind, imagine that bringing that perspective to the cloud, right? You have infrastructure as code, where every single resource that is deployed on the cloud platform is done through code, right? So with that, you're able to measure who deployed these resources because you know who executed the code. You're able to attribute the cost to that particular cost center or to that particular person. You're able to turn off resources, right? By leveraging different policies, you're able to bring in a certain level of expertise or technology that will help you govern idle resources. And then you're able to stop provisioning over provisioned resources, right? How do you do this? The next slide shows you exactly how, right? HashiCorp's Terraform has a beautiful set of tools, right? Apart from its IAC component itself, apart from the fact that it is an infrastructure as code provider, you have Terraform Sentinel. Terraform Sentinel is a policy as code engine. What does it do? As a code engine, it brings in a certain level of governance, it brings in consistency, and it brings in compliance into your infrastructure, right? It could be cost compliance, it could be resource compliance, it could be tagging. There's a lot of things that you can do with Sentinel, and we have Cheryl who's going to show you exactly how Sentinel works in real life, right? But think about a scenario where you have a set of developers who want to deploy infrastructure on AWS cloud, right? Now you're not going to let these developers deploy infrastructure that's going to be over provisioned, right? You want them to deploy infrastructure that has a set size that is meant for the development environment, right? That is meant for testing, that is meant for short-lived environments. So what they do is what you have is a Terraform Central policy that basically has a set of rules, and those rules basically define that, hey, this resource is meant for development. It can only be these particular sizes. It's going to last for this long. That means after a couple of hours or after a set amount of time, it's going to automatically deprovision itself. And these are the mandatory tags that have to be included as part of this template, right? So Sentinel brings those capabilities to you. Now, there are different models in which you can leverage Sentinel, right? But I'm just going to hand it over to Desmond, and Desmond's going to take you through various ways on how you can manage your cost and optimize it in AWS. Now, when at the end of Desmond's perspective, you'll be able to understand exactly how you can leverage Sentinel and continue to leverage these AWS cost tools. So, Desmond, over to you.
Thanks, Anirudh. So good morning, everyone. Desmond from the APJ Partner Core team. here to assist customers in achieving success when embarking their journey towards the cloud. So honored to have been invited to participate in this webinar session in collaboration with HashiCorp and AspireNXT, right? So let's talk about cost management and optimization when you are looking to embark your journey with the cloud in AWS, right? How do I fully unlock the value of the cloud for my organization, right? Now, when we talk about cost optimization, it is more than just cost saving, right? How much can I save at the end of the month for the organization? It's more than that. So optimizing your cost on AWS can allow you to do much more with less, right? Which in turn enables your organization to be more agile to meet your customers' needs, market disruptions, and of course, industry trends. Right? You can use these savings to invest back into your organization and innovate much faster. So how do we achieve all this, right? Next, please. Yep. Now, in AWS, every solution and design deployed will follow what we call well-architected framework, right? Which is a set of guidelines to help us build a secure and a high-performing environment. So one of these pillars is called a cost optimization pillar, which continually process, refine, and improve your workload over its life cycle. So always have this in the back of your head at all times when you approach every problem in the cloud, right? So first and foremost is adopt a consumption model. Don't run things and create things as and when. You need to run them and then be prepared to destroy them, right? Pay only for computing resources that you require and increase and decrease that usage depending on your business requirements. For example, development and test environments typically only used for, let's say, a few hours a day during the work week, right? Sounds like a basic concept, but it can actually potentially help you save up to around 75%. Okay. Second is must find a way to measure overall efficiency. We must measure the workload outputs and the cost of that output, right? Use this measure to know the gains you make from increasing output and reducing costs. Third is you're not really running a DC business. Now, if you are, that's a separate conversation altogether. But if you're not, no use in spending so much time managing manpower, cash flow, DC operations, right? Focus on your core business. So let AWS do the undifferentiated heavy lifting of racking, stacking, and powering your servers. Now, fourth, analyze and attribute costs granularly. Not really possible before cloud. So think of, let's say, a network switch. Do you allocate every port? How about its power, its heat, right? How do you allocate cost to that? So the cloud gives you opportunity to drive efficiency and be lean like never before, right? You can accurately identify the usage and cost of this system, and in turn, return on it gives you a measure for ROI and gives workload owners opportunity to optimize resource and reduce costs. So lastly is to use, manage, and application level services. So same as the data center argument, keep pushing up the stack, right? Use managed services as much as possible, right? Nadia, next. Okay, so as part of the design process in AWS, we follow best practices in WEF to ensure you can realize economic benefits of the cloud. So first of all is expenditure awareness at a high level. Where is your money going, right? What are you getting for it? And how to drive its efficiency, right? Next is cost-effective resources. Getting the right resource for the right job. Okay. Third, matching supply and demand. Okay? Don't jump into just elasticity and auto scaling. How about utilizing buffering, right? Everyone always focuses on supply. How do we cater for demand, right? Optimizing over time, right? The last one, workloads spend most of the time running. How do we make sure that it's optimal over the entire life cycle? How do we adjust accordingly to external factors and influences, right? So this is just a 50,000 feet in the air kind of prescribed best practices. Let's deep dive a little bit more into each area. Okay, let the slides play out, Nadia. So for expenditure awareness considerations, I think it goes without saying that to understand your organization costs and drivers is very critical and key to manage your usage effectively. So first step to saving and optimizing is to understand where you are spending it on, right? So the first thing we talk about is governance, right? In governance, we do have policies based on your organization requirements, which can implement cost control account structure. We implement things like account groups, roles, and then we can use that to track a project over its life cycle. So next is what we call monitoring. How do we monitor what we are using? So we have tools such as AWS cost and usage reports that helps us categorize and identify the cost categories, right? And then establish a specific organization matrix, and then define that with implementing things such as tagging strategy, right? And lastly, of course, once you've identified that, we have things that helps with resource decommissioning, implement a proper decom process. Rather than doing it manually, there are ways that we can do it automatically and periodically, right? So next. In the cost effectiveness resources consideration, we actually evaluate costs when selecting services, right? So identify organization requirements for cost is key, and then analyze all components for a workload and perform a thorough analysis of each component, right? Now, once we've done that, we can meet these costs by selecting the right types and sizes. So we have many different services for different kinds of workloads. We want to make sure that we are selecting the right resource types and size that based on estimates and of course, matrix, right? The third is using pricing models to reduce costs, implement different pricing models with low coverage, and implement regions based on cost. Not all region is the same costing, right? And of course, this being cloud, we have to plan for data transfer charges. There will be data transfers in play when we implement workloads within the cloud. So selecting components to optimize data transfer costs is key, and implementing services to reduce these data transfer costs. Okay, next. So when you move to the cloud, you pay for only what you need, and you can supply resources to match that kind of workloads at the demand and when they are needed, right? So remember when I say you can modify demand, you can actually achieve that with buffers and throttles and queues to smooth demand and serve it with less resources, right? So we perform an analysis on the workload demand, know the requirements, and then use that to determine which kind of supply to match that kind of demand, right? And we do that via scaling mechanisms. Okay, next. So cost optimization is actually a journey, not a race to the finish line. So as AWS releases new services and features, it is a best practice to review the existing architectural decisions to ensure that they remain cost effective. So as your requirements change over time, you might decommission resources and workloads that you no longer require. So consider the following when you optimize over time, right? Develop a workload review process, review and analyze this workload regularly, and of course, keep up to date with new service releases. Yeah. Next. So AWS has a set of solutions to help customers with cost management and the optimization experience. So this includes a whole host of services, tools, resources to actually help you achieve all the necessary best practice as discussed earlier. And this slide actually just shows the mapping of each service to match the stage of your journey to cost optimization, right? So moving on to the next step, we'll talk a bit about customer success stories that has implemented cost optimization measures with AWS. So Arista Group is one of the largest automotive dealers in Indonesia, and they were previously with a different cloud vendor, and every month their bills were just increasing tremendously. At one time, nearly doubled every month. This is due to the lack of holistic monitoring and visibility into their cloud spend, right? So utilizing and partnering with a consulting partner, a trusted partner, they actually moved over to AWS. And with our tools such as Cost Explorer and Cost Usage Report, they actually gain a very good visibility into how are they spending costs every month. This allows them to actually better plan for the future. It actually helped them reduce costs by 20% monthly. And of course, with that savings, expanded their business from 80 to 117 branches in just 1 year, right? The next one, this is actually one of Wing Music, the biggest, I would say, streaming service in India for music and entertainment. So as you know, this kind of apps would generate a large amount of terabytes daily to deal with things like analytics and insight into customers' preference and base, right? So with this influx of data, definitely cost is going to be driven up tremendously. But with visibility into what kind of data they have, they are able to utilize different kind of resources, such as spot and on-demand instances for their data processing. This actually, again, drives down the compute need and compute costs by 60%. And because it is in a AWS cloud model, they actually lowered their time to market from 6 days to actually half a day, right? Next. And this is just a visual of showing you how our other customers around the world has actually utilized spot instances to match it with the right workload demands, all right? And this is just a bird's eye view for your reference. Okay, next, and with that comes to the end of my presentation on cost optimization in AWS. I hope that it's insightful for everyone here. Now, since the presentation is coming to an end, we'll have a short polling session to wake everyone up and jog your memory on what we have presented. So as you can see here within your window, you will see kind of like a polling quiz time. So please put in your inputs and your answers. There will be 2 questions here. We'll give it for maybe about a minute, or maybe even less if everyone has answered.
Looks like everyone's a little torn on the well-architected best practice.
Indeed. So I think answers right now are pretty distributed evenly across all 4. Okay, so the poll has ended. Anirudh, if you would like to take the first question of the quiz.
Yes, thank you. So, the benefits of infrastructure as code. Now, let's look at each answer, right? Fast speed and consistency. Yes, it reduces the time it takes operations to deploy infrastructure. Think about the reusability of, Terraform. You just have to write the code once and execute many times as you want. Efficient SDLC. Yes, it does bring efficiency to the SDLC because in the whole DevOps process, um, you basically are cutting out time that it takes for the ops to do it, right? So again, coming back to point one, because of better consistency and faster speed, you have a more efficient SDLC. Reduce management overhead for sure. You no longer have to ensure that tagging is done. You no longer have to ensure that it's been deployed in a certain way. You don't have to ensure that certain processes were followed to meet compliance. As long as it's present in the code, it's available on the platform also. So with that, all of the above is the correct answer. Over to you, Desmond, for the second question.
Thanks, Anirudh. So the second question is to deal with well-architected best practices for cost optimization, but there is a catch. The catch is which one is not part of that best practice, right? So let's go through the available options. We'll go from bottom up. Optimizing over time. So as mentioned before, what works well for you back then might not be true few months or few years down the line as your demand changes, as more services are being rolled out. We have to evaluate that demand and supply over time. And that brings back to matching supply and demand. How do we effectively match supply versus demand? Are there tools that we can use to smooth demand over time, a certain time period? And of course, can we scale our workloads back end to supply that demand, right? And as we move up, cost-effective resources, definitely. We try to match the best type of resource in particular region because everything is differently priced. Try to match back which works best for us with the least amount possible, right? Now the last one, or should I say the first one, option is called enable traceability. That is actually also part of well-architected best practices, but for the security pillar. This allows us to trace back threats from external and internal possibilities, right? So it's a bit of a trick question. Looks like it's the right question, but the odd one here is the enable traceability option. Yeah. So thank you all for participating in the poll. Now you've seen me and Anirudh present. It is actually time to see things into action. So I will pass the session over to Cheryl to run through a short demo session. So Cheryl, over to you.
All right, thank you, Desmond. Now I'm gonna share my screen. Let's see. Okay, just to confirm, is my screen visible?
Yep.
You see the okay,
Yep.
the Terraform on cloud UI. So everybody, I think you have heard how we can, not only use IAC for faster consistency with your infrastructure, building of your infrastructure as code. And then also we heard from Desmond on how you can, put in some mechanisms, some methods to use in optimizing for your costs in the AWS console, right? So what I'm going to show you right now is how you can actually leverage Terraform, the infrastructure as code tool, to also help with cost optimization, how you can put in guardrails, especially as you move towards, the cloud, you get more workloads on there, right? So what kind of controls that you can have? I think first, so this is the Terraform Cloud GUI. If you do not have a Terraform Cloud account, feel free to go and create an account right now. It is free. We have a free tier. But of course, you know, quite a few of the things that I'm going to show you is part of the enterprise tier, right? But you know, if you need to explore those enterprise features, feel free to reach out to, you know, probably Anirudh or the AspireNXT team or even the HashiCorp team, and we'll be able to, you know, provision a demo environment for you as well. But anyway, let's get to it. So this is a workspace, right? A workspace is essentially your Terraform code, where all your Terraform code runs. You know, this is the workflow at which you would see your Terraform code running and deploying your infrastructure. So this is a workspace that is generally just provisioning a very basic AWS instance, right? If I actually look at the, you know, over here on the right, okay, wait, actually, I'm going to zoom in a bit more so that's easier to see. Yeah, so on the right here, you see, I think you will notice like a GitHub logo, right? And this workspace is actually tied to my GitHub repo. And this is one of the benefits of, you know, using infrastructure as code, right? Because, you know, with infrastructure as code, if everything is via code, you can, you know, leverage the same benefits of like a version control systems, not only for your applications development, but for your, you know, infrastructure building as well. So if I look at my code itself, right? This is my folder. This is my Terraform folder that is connected to my workspace in Terraform Cloud. And this is a very simple folder structure, but you know, if as you go on and grow in your usage, it might become a bit more complex, right? But typically it looks like this. You have your main.tf and you have your variables.tf. So your main.tf is essentially the code at which Terraform will read to, you know, decide what it needs to provision, right? So in this case, we are using the provider of AWS. And also to talk about a little bit about the concept of providers, essentially think of them like plugins that you can integrate with Terraform. We have a provider registry where you can Google for it. And you can already see all the different providers that we integrate with. And you know, you can reference their documentation and then you can configure your code accordingly, right? So in our case right now, we are looking at a provider for AWS, and we have also set a region. Then in the second part of the code, you see that there is a resource, you know, the AWS instance, and we have named it app. And this is typically the basic configuration that you would put in, right? Your instance type, what availability zone, what's the AMI, how many counts of like the instance that you want to spin up, right? And also we have, you know, you also can comment your code. So as you can see, I have some commented code right here. And essentially the language that we are also using to define our Terraform code is via the HCL, HashiCorp configuration language. So it's both human readable as well as machine readable. So this is the main.tf code, right? And then we look at the variables.tf, right? So if you saw in the main.tf code, right, you saw, you know, you would have seen like var.region or var.zone. So of course, as much as possible, you should, you know, preferably not hard code your whole entire code, because you know, what if you need to change something? If you need to change something like, and it appears in multiple locations, you have to go to multiple locations to like modify the code, right? So if you use variables, it is all, you know, you can create like default variables and configure them within the Terraform environment itself. So these are all the different variables we have set, you know, for region, for zone, for instance type, as well as instance count, and we have also set default variables for all. So back to the Terraform Cloud UI. So right now, I am actually going to start a new plan. So Terraform follows this workflow, and it's the same regardless of what infrastructure you are provisioning. You will always go and do a plan. After you do a plan, you will do an apply. And then, you know, this is the typical workflow. And then if you want to destroy your project, you want to deprovision everything, then you do a Terraform destroy. So you see that momentarily. So I am going to trigger a plan, right? And, you know, from here, we can see that the plan is running. Now, the Terraform Cloud is actually in, you know, connecting with the AWS API to provision this AWS instance. And as we can see over here, from the plan itself, we can already tell how many resources would be created, right? So from a customer's perspective, you'll be able to see, okay, you know, at a bird's eye view glance, what would happen, right, for yourself. Then after which, you know, this is one of the enterprise features that we have enabled. So just a disclaimer, Terraform is not a cost optimization tool, right? We do not do that. We just provide you an estimate base of what you want to provision. So based off this estimate, we can determine, okay, you know, if you want to provision this AWS instance, it's going to cost possibly $35.52. So this is an estimate, right? And then another enterprise feature that actually got enabled is this thing called the policy checks. So policy checks are done by Sentinel. So Sentinel is our policy as code framework. And essentially what you can see here is that I have two Sentinel checks running over here. One is to restrict the EC2 type instance. And secondly, the cost at which my instance to be provisioned should be less than $100. Like total, if I total up everything, it should be less than $100. So I know it's very simple, but you can from here, you can really tell, right? Like what are the different policy checks that you can put in place to restrict like the instance type, right? Because I think, you know, especially when we go to the cloud and, you know, we have so many like AMIs, so many images that we can choose from. You know, if you give your developers like free reign to choose anything that they want, then of course you definitely hit those problems of like, you know, like extravagant costs, you know, that the company has to pay. And, you know, if we also put in like a cost estimate and, you know, we take that cost estimate and determine like, okay, hey, as long as you are provisioning something within the budget, you know, let's go with it, right? Just go and provision. The thing about why policy checks, automated policy checks are so important as well is because, like, you know, previously, if you don't have an automated policy check, what would happen is typically, you know, as a developer, I would want to provision something. Then before I can provision something, I need to go to IT ops first. Then after IT ops, you know, it takes maybe 1 week, 2 weeks to look at the code and gives an approval. Then only I can provision, right? So, you know, it really defeats the whole entire purpose of moving to the public cloud and, you know, getting that agility, that development agility, right? So, you know, with this, at least everything is automated. And as long as you have passed the policy checks, you will be able to just provision and, you know, go about your duties as a developer. So, you know, once I've seen the plan, I've passed the policy checks, then I can confirm my plan, right? And once we hit confirm, this is when Terraform will say like, hey, okay, you have confirmed this is what you want to run. I will now provision what you have intended to in AWS itself, right? So the apply is now running. And also I just wanted, so while that is running, right, I think I just want to show you what the Sentinel policy also looks like. So over here, before we go into that, this is a policy set that I have enabled within my organization, right? So if you go into the settings up top here and you hit policy sets, this is the cost estimation TFCV policy set that I've created. Is actually within my GitHub. And I have enforced this policy on a selected workspace, which is the basic AWS _instance. Okay, so let's go into GitHub itself. As you can see, so putting policy as code as well, we reap the benefits of a version control system, right? Any changes that you want to make, you know, you can easily do it. And it's all audited and tracked. So if we look at this, this is essentially the less than 100 cost estimation policy. So it just, this is typically how a code would look like. So you will determine your delta monthly cost, you know, you will take that value, and then we will say like, okay, this delta monthly cost, it has to be less than 100. So this is one policy. Secondly, we have this restrict EC2 instance. So right now, the allowed type instance, as you can see from here, it is T2 micro, T2 small, and T2 medium. So just now, why I got true is because it was a T2 medium, right? I didn't change any values. I'm using the default, and the default is within the acceptable range. So right now, if I see this, get all the EC2 instance from the plan, right? From the Terraform plan, we find the resources stating AWS_instance. After which, we find this and we see whether it violates the rules of the allowed type. So if it violates, then of course, we will see an error and we probably might not be able to provision. But also one more thing, there are different enforcement levels that you could enable. So we have three levels, right? So we have soft mandatory, we have hard mandatory, and then we have advisory. So a soft mandatory check, as you can see here, is that if you fail the policy check and you have the capabilities to override that policy, then you can override it and continue to apply. But hard mandatory checks are checks where there is no loophole where you can bypass it. Essentially, if you fail this policy check, it's a hard mandatory. Terraform, there is no way for you to override, even though you probably have like some power of overriding policies. So this is hard mandatory and soft mandatory. Then the last one, the most basic one is advisory. Essentially, it's just going to say like, it's just going to put a warning and say like, hey, you have failed this policy, but it's just an advisory. You can just move on. There's nothing for you to approve or deny or etc. So this is how it looks like. And as you can see, the apply is finished. This AWS instance has been created within AWS and with this ID itself. Also, one more thing I want to run through with you is to talk about variables. You're probably wondering like, how is Terraform verifying itself or authenticating itself with AWS, right? And determining where I'm supposed to provision something. So this is where, right? Variables come in here. These are all secured by Vault. So Vault is a secrets management tool by HashiCorp. We are using that to encrypt your data as well. So AWS access keys, you would see here, and then the secret access key and the session token. You would have to put all these variables down. It will depend, it will vary depending on which provider you are using. But for AWS, it's these three that is needed. And these three are environment variables. You will see your AWS access keys that you need to provision and a secret key. So the thing about this, especially the secret key, is we have marked this as sensitive, right? So as you can see, sensitive means it's write only. So being write only means like, even if I try to edit it, I cannot see the variable at all. But this value is not a sensitive variable. So if I try to edit it, I can edit it, right? So this is essentially just, different ways at which you can mark and protect your data. So right now I am just going to also show you one more thing. What is the benefits of actually moving, actually two more things, right? So so what's the benefit of actually also using your version control system is that there is also a webhook, right, that we have with AWS. Not AWS, version control systems. So if I edit this, right, and I do it over here, I say the default is 2, right? Oh no, 3. I think I'm going to do it 3 so I can show you policies kicking in. So I'm just going to quickly just commit it to branch. What you will see is that a run would suddenly happen over in Terraform. As you can see, it just kicked in, right? So there's always a webhook between Terraform and the version control system itself. And it's like we are always, why this is important, right, is because, we want to ensure that the code on both ends and what you should be, you want to deploy is always in sync, right? So a plan is now running. And now we're going to go into the details. We're going to see the policy checks, right? So in our case, 2, I didn't put 3. Okay, so I put 2. So in the end, the policy check still passed. Right, so but essentially this is what happens. I didn't trigger a check from here, or I didn't trigger a run from here. I triggered it from the version control systems. You can also update your variables, your Terraform variables, as you've seen earlier, like the region, the instance count, etc. You can add a variable here, put it as Terraform variable, enter the key, enter the value, and then save it. And on your next apply, we will read this value and run your code. So now I'm just going to do a destroy to show you the entire workflow. Typically what happens. So basic instance. I'm going to discard the previous run. So as you can see, you only can run one thing at a time, right? This is to ensure, because when you're using a SaaS tool, you're probably going to have more than just one person. You're probably going to have like maybe 5 people running, and you don't want like different codes to be like going against each other. So that's why, as you can see just now, I had a plan running previously. I didn't proceed with it. I didn't discard it. So that's why it's still hanging over there. And before I could trigger the destroy, it had to ask me whether I wanted to discard that run. Right, so now we as you can see, we are actually destroying our instance within AWS itself. I'm going to confirm the apply, and that is it. Right, so I hope from this demo itself, you could see how you could leverage Terraform. So if you don't even use Terraform right now, go and create a Terraform Cloud account. It is free. You can go to app.terraform.io to create an account. You have seen, to summarize what you have seen our cost estimation tool in place. You've seen how we have used that cost estimation tool and input those values into our policy checks. You have seen how we have integrated our workspace with the version control systems. And you have seen how each where we can trigger different runs, either via Terraform Cloud itself or via making changes within your GitHub or your version control system. And we have also seen Sentinel policies. So that is all that I have for my demo. Open to any questions right now. And I'm passing the time back to Nadia for the slides. Thank you.
Thank you, Cheryl. So we're just going to go into a quick Q&A session. I see that there are already 2 questions, and there's one more question. Cheryl, I'm going to let you just look over the already answered questions if you wanted to add anything to it. When or how frequently should you apply IAC changes? So the beauty of infrastructure as code is it can be used, one, for managing new deployments, as well as managing changes to existing deployments, right? So if you have a set SDLC, it would definitely make sure to it would definitely make sense to put this within your SDLC. If you're looking at a little more random structure of deployments, then as and when required, you can go ahead and apply these infrastructure as code templates. As for changes, like I said, it's either could follow your DevOps process or your SDLC process, or if you have a governance around that changes have to happen every 2 weeks because of a patching or something, then you can go ahead and leverage IAC to do it in that time frame too. Right, I'm just going to, if you guys have any more questions, please go ahead and put them in the question and answer section, and we'd be able to definitely answer them. While you do that, I think, Nadia, if we can move to the next slide, while we wait for a few more questions to come in, let's see how you as attendees can engage with us, right? So there are a few ways, a few call to actions that we have for this webinar. If you guys want to, anyone wants to experience a one-on-one experience, please go ahead and just, drop us a message or through the feedback form, answer if you want to go ahead and experience a one-on-one hands-on workshop with us. That if you want to go ahead into a deep dive, you can in cost optimization for your environment. We have the skill sets to bring cost optimization exercise into your environment, so that's also something you can do. Or if you want to have a joint session with AspireNXT and HashiCorp and AWS, and see how we can bring these technologies into your environment, into your industry, that's also another way to engage us. Apart from the engagement, we are also having special bundle offers on the infrastructure automation bundles from HashiCorp. So as you can see, there are 3 different bundles on the screen, and you can go ahead and use any of these bundles for your organization. Right? I see that we've got one more question. How do you test my infrastructure code? So I'm gonna actually ask Cheryl to answer this. So Cheryl, if you want to take this from a Terraform perspective on how testing happens.
Let's see how to test my infrastructure as code. Right. So, just now as what you have seen, right, before you actually could do and apply for your infrastructure, we actually did a plan, right? So I don't know whether you noticed, we ran through to see based on the code, what would actually appear in your provisioning in the actual environment, right? So this testing is part of the entire workflow for Terraform. So we're always going to use the workflow of plan before you do the actual provisioning, which is apply and then destroy, right? So the plan is how you would test your infrastructure as code. I hope that answers the question. If not, feel free to elaborate if, in case I missed out or probably misunderstood your point.
So I think you've hit the nail on the head with that answer, Cheryl. Thanks.
One more thing I want to add, right, is that we can do a there's this a command for Terraform. Oh shit, I have it's lost in my head right now, but there is a command that you could execute, right? If you use the command line, it allows you to verify your Terraform code. Okay, so we don't verify the logic, right? But we can verify whether you have, probably did some you missed out a colon, or you missed out on naming something properly. There is validate. Yes, thank you, Anirudh. Yes, Terraform validate. Yeah, so that is probably also one way that you can use that to test your code. Yeah, thanks, Anirudh.
Thanks so much, Cheryl. So yeah, with that, I think we can come to the end of our webinar. I thank everyone who's sat in with us and listened to us. And if you guys want to definitely engage, just go ahead and drop us an email or just respond to the feedback session, and someone from our team will be in touch with you. From our team here in AspireNXT, the HashiCorp team, and from AWS, I'm wishing everyone a good day, and thank you again.